In today's video on the Cadillac 472-500, I'm going to talk about the stock rocker arms. Now, I know a lot of guys don't like these, but I kind of feel like they get a bad rap. They are a different design. It has this little spring clip that holds the rocker onto a cast T-pedestal that bolts down, and the rocker sits on either side. Now, these rockers were actually originally designed for the 429, though I don't know if they quite got to the 429. So they went ahead and used them in the 472 when it came out because it was their new design rocker. Now, a lot of guys will tell you they break. You know, the little arm breaks, the T-pedestal breaks, and that can be true. But part of that is because they don't really understand the rocker arm, and they may not understand what's going on in the motor. Now, just like we talked about when we did springs, is one worry is that you have enough room. If everything binds up because you put in a bigger cam, then you're going to spit parts. And the weakest point in the system is probably these rocker arms. But that doesn't necessarily mean they are a weak piece. I have run them for years. I have run them with higher lift. I have run them with more spring pressure. I have run them with lots of RPM. And I have very little trouble. With an H11 spring, which we were talking about a spring that's like 320, 330 open pressure, I did break one stand. And that's been it. And I've had one of these tins break an arm off here. That was early on in the 80s, and it actually had a little fracture. So I started making sure I looked at the tins, because sometimes when they folded these arms up, they actually made a little crease point down here, and it would have broken from the factory. So you do need to inspect the parts and make sure everything looks good. Now, like I said, we were careful about how much spring pressure is going on this motor because I didn't want to go too high and have trouble with the rocker arms. Plus, remember, we're running a stock camshaft in this thing. So I don't have to worry about the cam. And that's the other mistake guys make, is on the camshaft. If you run a lot higher rate cam, and rate is how fast the camshaft moves the rocker off of the seat, how fast the lifter starts moving. And stock stuff moves fairly slowly. It opens slowly, it closes slowly. So it's fairly nice to the rocker arm. If you were to throw something in that had a lot of rate, because the cam manufacturer tells you, well, this will make a lot more power. Well, that puts a lot more strain on the rocker arm. And that can be one of the problems that guys have trouble. Now, for years, and they're gone now, but I used crane cams for the very reason that the rate was slower on them. And some guys used to complain about the crane cam because of that. Well, it's so slow. It's very conservative on how it opens and closes. And comp says that their cam will make more horsepower. Well, if you're opening it faster, yeah, you can make more horsepower. But it's also harder on parts. And so you got to be thinking about what you're doing. If you're just building, kind of a stocker motor, a little better than stock, you don't necessarily want to buy new rockers. If your set's looking pretty good, not all wore out. I mean, they have a flat tip. So, sometimes these wear and the rocker's no good. But you can see, I mean, it just has a tip that slides over the valve as it rocks. And so if you're wanting to run these, you need to pick a cam with a slower ramp. And there are cams out there that way. Or you can get one ground that way. And, places like CAD Company will have friendly cams for stock rockers. And what they are is just a slower ramp so that you don't have trouble. Now, it'll probably give you a little more duration, maybe a little more lope, but it'll let you run the stock rocker, and you can avoid the cost. And like I said, if your rockers are in good shape. Now, the other thing that people don't understand about these rockers, and this gets them in trouble and why sometimes they tend to break them, is they don't understand how the rocker works. Now, I'm going to try and roll this over. And if you look here, the rocker starts on the back edge on the tip of the valve. And then as you roll the motor, it moves. I'm trying to hold it steady and turn the motor over. It rolls out further and further. See, it's out at the edge now. And as it goes all the way open, it moves from the inside of the rocker arm to the outside of the rocker arm. Now, that's part of the reason why it has a pad, and why sometimes you don't see just a little circle here. What you see is a elongated circle. Now, you're saying, well, what's that mean? What's that matter? That's how it works. Well, what that means is that as you start out, and here's what I did. Maybe I'll tell you what I did. I plotted out with the degree wheel the tappet lifter, the lift at the lifter itself. And so I knew at what degree I had 50 thousandths tappet lift, 100 thousandths tappet lift, so on and so forth. And then I rigged up a dial indicator to show me how much valve lift I'm getting. And I've plotted this all out to try and show you. And if you look here, this is the degree I need to be at for the tappet lift. So at TDC, I have 28 thousandths tappet lift. At 9 degrees after TDC, I've got 50. 26 degrees, I've got 100. 41 degrees, I got 150, so on and so forth, all the way up to full lift. So I then plotted out and measured how much valve lift that was giving me. And you can see it going up like you would expect. But I've also then gone back and calculated the rocker ratio. And if you look here, the rocker ratio starts way low and works its way up to 1.7. You know, it's not at 1.7 until almost full lift. And that's because that pad is changing its position on the tip of the rocker as it goes. And one of the things that comes up fairly often with the Cadillac is what ratio is the rocker? Why do the books show two different ratios? Why is there a difference? What lift am I going to be at? Well, it changes. It changes through the whole thing. And depending on how they have the rocker in there and how much lift the particular cam they're running has, the ratio actually changes a little bit. And you can see here, I did get up to the 1.7. And usually they say that the rocker is like 1.72. Now, this is where it gets to be a problem. Because it's sliding across the tip, if you put in a camshaft with more lobe lift, the ratio keeps going up. So up here, I preloaded it and basically mimicked what 310 tappet lift would look like with the stock rocker arm. And 310 lobe lift is not uncommon in an aftermarket cam. That gave me 550 lift, and the rocker ratio went all the way up to 1.774. And that's where the problem is. A lot of guys will say, okay, I need clearance on the valve with a 1:6:5 ratio for this much lift, and that's all they do. And that's why when we were talking about springs, I kept saying you need to leave extra room. Because in a race motor, I mean, a lot of guys will tell you, in a race motor, you want the spring to be close to solid at your full lift. That helps the spring not go into oscillation or bounce. But this is a street motor. I don't have a lot of spring pressure. If I do run into trouble, I could probably up the spring pressure a little bit, but I'm running a stock cam. I don't expect to have a lot of trouble. But if you don't leave extra room, then you don't really know what the rocker ratio is. Then suddenly things start going solid and you start breaking parts. And you don't understand why. Well, I know I have room because it's only 1.65 ratio. That's what the cam card said. Well, the stock rocker not necessarily is. And sometimes they list it as 1.7. And like I said, some of that is the cam. Some of that I have found, though it's really hard to measure, that on some heads, they actually move this back or forth just a smidge. We're talking a few thousandths in order to push around where that tip is pressing. And so you really got to think about what you're doing. And I've known about this for years. I mean, I tried to explain it to people that this high ratio is going to just keep going up. And so, like I said, that's usually where guys run into trouble. Things hit, either valve to piston or retainer to top a guide, or spring goes solid because they only put in a spring that was good for 500 or 550 lift. So they may literally be right at the limit of what the spring can do. So the spring may be going solid on them. And so you really got to look at what you're doing. And that's why I pushed for the 600 spring when I was doing it, is to give me some breathing room so with the stock rocker, I'm not going to have any trouble. Now, to show you something, I also took a rocker that I've been working on, and I've been designing a new drop-in rocker arm, or trying to. It's hard to get everything square. But this is a 1:8:5 ratio rocker. And I bolted this up with my pedestal, partly because I wanted to see where it was sitting. But I wanted to show you guys. Now, it starts out a little low too, but it pretty quickly gets to its ratio. And partly that's because on a roller tip rocker, the tip is rolling across the top of the valve. And so the ratio, which is the distance from here to here, never changes. So the only thing that's affecting me with this rocker arm is the cup here and the geometry, which I'm not going to get into, but the geometry of how the push rod is pushing up on the rocker arm. Now, I did this test partly for me because I wanted to see how the rocker. I can fix some of this by trying to get the rocker to sit a little lower. This drop in ratio is how the push rod's coming in. And if I come in a little lower, I can get that number up to where I am using more of the ratio of the rocker arm. And having it just a little off is not uncommon in a rocker arm. I mean, they are not flawless at the exact ratio. So a lot of guys like roller tip rockers. They feel like they make more power. And part of that's because you're not changing the ratio. I mean, look at this. I mean, this is starting at 143. This one is starting at 168. So that's going to change the cam dynamics by basically opening the valve faster, just like the faster ramp I was talking about. And that's part of the reason I was kind of working on these for maybe a stock motor as a drop-in. Instead of you putting in a bigger cam, you might be able to run just a higher ratio rocker and pick up some horsepower. So that was the basic idea on the design of this rocker that I'm working on. And it's still got a lot of work to go. I mean, it's obviously not sitting in exactly right. So I need to move it over. It's off on the tip. But that's not what I'm showing here. With the stock ratio, you can see it changes and it keeps going. And at some point, of course, you fall off the tip if you go with enough lift. So you need to be thinking about what you're doing if you're running the stock rocker arm. And it'll keep you out of trouble. I have understood this for years, and this is part of the reason, and I've tried to explain to guys, but this is part of the reason I don't have near the trouble with stock rocker arms that other people do. Because I make sure I have some extra room, and I know that the ratio is probably going to be higher. This is also why I started looking at even higher ratio rocker arms. If you go from, a 177, say I was running more lift, and you drop in a 160 rocker arm like those cheapies, well, I'm actually going to lose lift. So that's really not helping me. So you got to think about what you're doing, and that's kind of the down low about the stock rocker arm. Its ratio actually changes depending on where it's going, and you got to understand that. And if you do, and you leave extra room like I did here, then you can get away with a lot more on these stock rockers than guys will tell you they've gotten away with. And it'll help you in the long run keep the cost down if you're trying to build a basically stocker motor. So remember that the ratio changes because it slides across the tip of the valve. And so think about what you're doing, and good luck in all your stuff. And at this point, I guess I can take this head off and get all the springs back on it and put this motor back together so I can run it. So I wish you luck with all your projects, and I'll talk to you later.